we're going to talk about quadratic functions and their models. So homeworks are usually due on Tuesday. So objectives, we're going to learn basic concepts about quadratic functions and their graphs, use vertex form and the vertex formula, complete the square to find the vertex form, graph the quadratic function by hand, solve applications and model data, use quadratic regression to model data. Not quite. In the interest of time. So here, the formula for a quadratic function is different from that of a linear function because it contains an x squared term. Let a, b, and c be constants with a equal to 0. A function represented by f of x is equal to ax squared plus bx plus c is a quadratic function. The parent function of all quadratics is x squared. So if I wanted to graph a couple of points here by hand, I want to make sure that I get the I graph the vertex. So -2, wherever I see an x, I'm going to substitute a -2 and I'm going to square it. That's going to be a +4. Make sure you check your calculator that you're actually doing exactly entering the values right, because if not, you'll be getting negative answers, which is obviously not correct. So be careful, practice with your calculators. So it's going to be 2 squared, this is 4, and 3 squared, it's going to give us 9. So let me graph these points. You can graph them, pause the video and graph them faster. So this right here, this point, this point right here that I'm going to highlight in green is the vertex. It's technically the turning point where the parabola changes from increasing to decreasing. And connecting the graph here, going through the vertex, there is an imaginary line that cuts it perfectly symmetrically in half. And this is called the axis of symmetry. It is not part of the graph. And the axis of symmetry, since it's a vertical line, is always going to be x equal to some number. And for this particular problem, we'll fill it out right now. Let me go back to my purple. So since it's symmetrical, this point right here is 3 spaces to the right of the axis of symmetry. So I can go 3 spaces to the left and end up here to get the other point on the parabola. And connecting the dots, here's my parabola. The coordinates of my vertex, right here, my vertex is technically 0, 0. And because of this 0 right here, x equal to 0, that same 0 is my equation for my axis of symmetry. So the shape is definitely a parabola. Let me go back to my purple here. My domain is, it'd be nice if you could pause the video here, and it's very important for you to know domain, range, increasing, decreasing, especially if you're barely beginning your math classes here. So please pause it. So our domain, hopefully we're checking our answers now, is, again, it's going to be our x's. What happened? My Apple Pencil is not cooperating. Let's see. What's going on? That's what's going on. See if it'll survive with 5%. So our domain is always going to be our x's. Domain is always lowest comma highest. And in this case, it's going to be the x. So our lowest x, since this is going forever to the left, our answer is going to be negative infinity. And the rightmost part of the graph is going forever right. So that's going to be positive infinity. So that's our domain. Our range is going to be our y's. And I'm going to do that in a different color. It's going to be our y's. And again, our range is still lowest comma highest, but it's going to be lowest y comma highest y. So our lowest y is the y value for this point, which is technically this value right here. So our lowest y is 0 with a bracket. And our highest y, since our arrows are going forever up, it's going to be infinity. And I'm going to put here forever up. Now I'm going to use a highlight, and I'm going to highlight it red here, pinkish. So increasing again is the part of the graph that has a positive trend, like a positive slope. That's this part right here. And we're always going to use parentheses. So I'm going to go back here. So increasing and decreasing is always going to be in terms of x. So it's always going to be in terms of the x's. So for that part of the graph that I highlighted, my lowest x is technically this x right here. So it's going to be 0 because it's the leftmost part of the highlighted part of the graph. And the rightmost part of the highlighted graph goes forever to the right. So it's going to be infinity. And I'm going to put here forever right. Now, when is it decreasing? So it is decreasing. I'm going to highlight the decreasing part with a little gray here. So this part, this is the part of the graph that's decreasing. And so for decreasing, it's going to be still the x's. And it's going to be the lowest x comma the highest x. So here I'm going to put lowest x comma highest x of the part that's highlighted in gray only. So my lowest x, this thing goes forever to the left. So I'm going to put it here forever left. Well, forever left is negative infinity. And my highest x value on the gray shaded part of the graph, it's the rightmost part of the shaded gray shaded area of the graph, and it is 0. It's technically this 0 right there. And we're going to put it with parentheses. Okay. The effect of a on a graph of a quadratic function. So if a is greater than 0. So another way of saying a is greater than 0 is if a is a positive number. So a is a positive number. So for example, if I have f of x is equal to 1/3 x squared, well, the a is going to be this. So again, this a, which is this a, which is this a, which is this a, is the leading coefficient. And here I have for x in front of x squared being multiplied. Let's have another example. What if I have f of x is equal to 6x squared? So if you notice these two examples, the a's are both positive. So in that case, if you don't want to use your graphing calculator, it'd be nice if we didn't have to. We need to know that our parabola is going to be upward. It's going to be facing upward. And so the next scenario is a is less than 0. That means that a is a negative number. Then our parabola is going to be upside down or downwards. Again, examples, f of x is equal to negative 3/4 x squared, or f of x is equal to negative 5x squared. Again, looking at these are negative. That's going to make our parabola upside down. It says use the graph to find the following. Part A, the sign of the leading coefficient. So we don't even have an equation, but we have the graph. So for part A, since the parabola is upside down, A must be negative. B, the vertex. The vertex is this point right here. So our vertex is going to be negative 2, 2. And then for part C, the axis of symmetry. The axis of symmetry is the vertical line, imaginary, not part of the graph, that cuts the graph in half. And so a vertical line is always x equal to, and in the specific graph, x is always going to be equal to negative 2. And then D, intervals where f is increasing and where it's decreasing. So increasing and decreasing. So I'm going to highlight the increasing. That's really dark. Sorry. So increasing is this part of the graph up to here. And it's going to be always lowest x comma highest x. And in this particular problem, our lowest x is going to be negative infinity because it goes forever to the left. And our highest x stops at negative 2, always with parentheses. Now for decreasing, this is the part of the graph that is decreasing right here. And it's still lowest x comma highest x, so I'm not going to write that down. My lowest x is negative 2 with the parentheses, and my highest x is going to be infinity because this is the part of the graph that's going, excuse me, forever right. Very slowly, but it is definitely going forever right. Moving right along. And again, please pause, go as fast or as slow as you need. All right, another form of the quadratic function is f of x is equal to a parentheses x minus h squared plus k, where hk is the vertex. So this h, if you notice, is going to be always the opposite value of this one. So if this is a minus h, this is a h. If this were be a plus h, then this one would be a minus h. Always the opposite. And this k, whatever it is exactly this value going to be as well. So note the a has the same effect as previously mentioned. So on the previous page, if this a is positive, we're going to have an upward parabola. If it's negative, we're going to have a downward one. In this form, the vertex and the axis of symmetry are readily identifiable. So that's the pros about this one. So example, for f of x equal to negative 3 parentheses x minus 1 parentheses squared plus 2, identify the vertex and leading coefficient, then write the expression as f of x is equal to ax squared plus bx plus c. So just so you know that this form technically is called the general form. It's also called a standard form. Those are, again, two synonymous phrases, I guess. And this one, because it shows the vertex, is called the vertex form. There goes my Apple pencil. Okay. Yes, thank you for letting me know. So here, we're going to be able to find the vertex. So the vertex is going to be the opposite of this right here. So let me highlight here. So my vertex is of the form h comma k. So I'm going to find it's the x value is the opposite of this one. So it's going to be just 1. And my k is exactly whatever this value is right here. So it's going to be a 2. And that's my vertex, 1 comma 2. The next thing that it says the leading coefficient. So my leading coefficient is the number being multiplied in front of the parentheses. So my leading coefficient is going to be -3. And here again, it's negative. So we have a downward parabola. Then it says to write the expression as f of x equal to ax squared. So our goal is to have it in the form f of x is equal to ax squared plus bx plus c. And right now it is in this form. So the parentheses have got to go. So let me rewrite the problem that they gave us. All right. So in your previous math classes here, it'd be nice for you just to remember. Where can I put it? Oh no. Be nice to me, technology. Come on. Show up printed. Oh no. Be nice. And it's just on the page that I'm writing. Let's see. Try it again. Okay. So it'd be nice for us to remember that x minus 1 quantity squared is technically a shortcut for, if I were to distribute it, I square the first term, I square the last term, I'll put at the end, but I can't forget to multiply these two terms in the middle and then multiply it by 2. So -1 times x is -x times 2 is -2x's. And that would be nice because if we remembered that, because then I would just be able to write it right here. Now, if we don't remember that, then we just have a little extra step here. So we need to remember that x minus 1 squared is the same thing as x minus 1 times x minus 1. And then we probably remember FOIL. So x times x gives us the x squared. And then x times a minus 1 is going to give us the minus x. We do minus 1 times x gives us another minus x. And the minus 1 times a minus 1 gives us a plus 1. And if we combine them, we get x squared minus 2x plus 1. Again, right there. Okay. So then I already substituted it here, and then I have a plus 2. And then I'm just going to start distributing here. Again, I'm going to try starting to make my equation look like my goal. So -3 times x squared is going to be minus 3x squared. Minus 3 times a minus 2x is a plus 6x. And then we have a minus 3 times a plus 1 is going to give us a minus 3 and then plus 2. And so we're going to collect like terms now. Squareds only hang out with squared, so I have -3x squared plus 6x, because x's only hang out with x's, and the minus 3 and the plus 2 combine to give us a minus 1. want to complete the square to find the vertex. And so we're going to go from the general form, also called the standard form, to the vertex form by completing the square. And here's the conditions. If a quadratic expression can be written as x squared plus ex plus e over 2 quantity squared. So don't get all bent out of shape, hang tight. It looks ugly. Then it is a perfect trinomial and can be factored as. So if we have this type of quadratic equation, then we're going to change it because it's equal to, and we're going to change it to this form. This is our goal. And again, this goal is because in our vertex form, we want this little parenthesis squared. Okay, so the steps. So it says step to change from general form to vertex form. So number 1, change f of x to y. All right, so here, let me start the example and I'll go with the steps. So it says write f of x equal to negative 3x squared plus 6x minus 1 in the form f of x is equal to a parentheses x minus h quantity squared plus k, and identify the vertex. So I want you to notice something up front. We already have technically our answer. This right here is exactly what we had in the previous problem up at the top. So we already know our vertex form should be this right here. So these two highlighted in yellow are identical. So that's going to be, our goal is going to be this right here. And in order to write it, we need this process here. Okay, so step 1 says, instead of f of x, you're going to change it to y. So y is equal to negative 3x squared plus 6x minus 1. Okay. Step 2 says, isolate the x squared and the x's on the right side of the equation. I guess obviously just away from the y's. So here they're already on the right hand side. So the thing that's got to go is this minus 1. So I'm going to add 1 to both sides of the equation, keeping it still in balance. And so I'm going to have y plus 1 is equal to negative 3x squared plus 6x. And that's it. So this is going to be step 2. Now, step 3 says make sure that the a in ax squared is equal to 1. Well, right now, this is my a. So my a is equal to negative 3. And so I'm a little sad because it's not equal to 1, but that's okay. The negative 3 right now is multiplying, so we need to divide everything by negative 3. So to get rid of negative 3, we divide everything by negative 3. So let me rewrite the equation that I have. So y plus 1 is equal to negative 3x squared plus 6x. So I'm going to divide everything by negative 3 on the right hand side of the equation and everything by negative 3 on the left hand side of the equation. So right now, so far, I have y plus 1 divided by negative 3 is equal to, and I'm going to go ahead and break these apart into pieces. But if you know how to simplify and you can skip this step, more power to you. This would technically be, this would be negative 3x squared over negative 3 plus 6x over negative 3. So on the left-hand side, I still have y plus 1 over negative 3. But on the left-hand side, negative 3 divided by negative 3, anything divided by itself is going to be a 1. And so 1, well, I'll go ahead and put the 1. And then I have x squared. And then plus 6, so right here, divided by a negative 3 is going to be a negative 3 times x. So we're going to write that down as a minus 3x. Oh my goodness, 6 divided by negative 3 on a good day is 2. Goodness gracious. Oh, and I took out the mega digga eraser. So it's going to be minus, 1x squared minus, and this is going to be 2x. So that 1 is technically what we wanted. So we're happy now. And it's an understood one, because really the way it should be written down is y plus 1 over negative 3 is equal to x squared minus 2x. And we do have that understood one in front. Okay, so here looking at this goal that we have here, right here, I have this 1. It's the same red 1 that I have in my equation. And so now we need to make the little connection here. So I'm taking this really slow. The e is whatever number is in front of the x being multiplied. So in our little problem here, our e is going to be not just 2, but negative 2. It's going to be negative 2. All right. So going back to the steps technically, so here, this was, I guess, all of step 3. And now we're going to be on step 4. For step 4, it says take half of e. Okay, so I need to take half of e, which in this problem is going to be half of my negative 2. Well, half of negative 2 is negative 1. Okay, then I need to square. Sorry. So I took half of e, excuse me, and then I need to square my answer. So square your answer. So my answer was negative 1, and I'm going to square it. So that means that I get a positive 1. So I already squared it. And then the last thing that step 4 says is add the final result to both sides of the equation. Okay. So what was my original equation that I had so far? I had y plus 1 over negative 3 is equal to x squared minus 2x. And so I'm going to add the 1 to both sides of the equation. So this one right here, I'm going to add it here, and I'm going to add it here. All right, let's continue slowly here. So I'm going to rewrite this. I have y plus 1 over negative 3, and then I have a plus 1, is equal to x squared minus 2x plus 1. If the process is done correctly, this trinomial is factorable. So if you notice, let me go scroll right back up here. I'm going to use, so let me highlight it with this here. I'm going to use this right here. So I'm going to rewrite it. So in the parentheses, I'm going to have the x, and then I'm going to take e divided by 2. Well, e divided by 2, I'm going to highlight it, this right here. Oh, that was horrible. Sorry. Let me just draw an arrow. E divided by 2 is the same thing. What happened? E divided by 2 is the same thing as half of e. They're the same thing. So that means that here in this space, I'm going to put half of e. Well, here's half of e, and in this particular problem, half of e turned out to be minus 1. So I'm going to put a minus 1 right here. I'm going to close the parentheses, and I'm going to square it. And on the left hand side, I still have the y plus 1 over negative 3 and plus a 1. So that's step 4. And technically here, actually, it's rewrite your equation as a perfect square. This is what we just did right here on step 5. And actually for step 5, we should probably add some steps here. Rewrite your equation as a perfect square and then solve for y. And then rewrite y as f of x. So what do those steps mean? So I need to solve for y. So I need to get the y by itself. So now we're just going to be doing regular here algebra stuff. So the plus 1 has got to go. I'm going to subtract 1 to both sides. So I'm going to be left with y plus 1 over negative 3 is equal to parentheses x minus 1 quantity squared and then minus a 1. The next thing that's got to go is dividing by 3. And there goes my Apple Pencil. Sorry if you can hear my mic moving all over the place. So the negative 3 has to go. It's dividing. So to get rid of a division, I need to multiply everything by negative 3. So everything on the left-hand side and everything on the right-hand side by negative 3. So on the left-hand side, negative 3 divided by negative 3 simplifies to 1. 1 times y plus 1 is just y plus 1. Now here's the clincher. Let's not invent some new math here. This negative 3, we're going to multiply it with the x minus 1 squared, but we do not distribute it. So this is just going to be negative 3 times x minus 1 squared. And then this negative 3, we're going to multiply it with the minus 1. So negative 3 times the minus 1 on a good day is going to be plus 1. Excuse me, a negative 3 times a minus 1 is a plus 3. Jeez. And then we're going to, the y is almost by itself. I need to get rid of that plus 1. So I'm going to get rid of the plus 1 by subtracting 1. And that's going to be right here. And then we're going to get y is equal to negative 3 parentheses x minus 1 squared plus 2. And that definitely jives with what we have up here up at the top. There it is. One last step is to change the y to f of x. So f of x is equal to negative 3 parentheses x minus 1 squared plus 2. There you go. So let's compare these. I put here to find the vertex in f of x equal to ax squared plus bx plus c, we can use x equal to negative b over 2a to find the x value of the vertex. So this formula is very important whenever you're given this right here. When you're given the general form or the standard form, which is this right here, the vertex isn't readily available. You can't see it. But you need to use this formula to find the x value. And then once you find the x value, you can substitute it to find the y value to get your vertex. And we'll see that right now. So what I just said mathematically is technically that right there. So let's compare the vertex form and the general form. So vertex form was negative 3 parentheses x minus 1 quantity squared plus 2. And the general form is f of x equal to negative 3x squared plus 6x minus 1. We saw that we went from one form to the other and vice versa. So they are the same graph. If you were to graph them on Desmos, it would be one graph right on top of the other. You can pause the video and check that for yourself. So we know here that, well, hopefully we would know that our a, which is this value right here, is negative 3 on both of them. So our a on both of them is negative 3. And so our shape, since a is equal to negative 3, our shape is going to be a downward parabola. And that's readily, again, you can see it with both forms. So the vertex. So the vertex in the vertex form is h comma k. So it's the opposite of whatever the h is. So on this one, because we have this minus 1, then our h is going to be the opposite. It's going to be a positive one. And because we have this plus 2, our y value is exactly whatever that is. And so there's our vertex form, 1 comma 2. So if you look in the general form, there's no way we can tell what the vertex is. So pretending we're not going to graph it, well, we're not going to graph it. We're going to use the formula. So this is going to be x is equal to negative b over 2a is the formula to find the x value. So we need to know that the a, again, is this negative 3. It's always the number in front of the variable squared. The b is going to be 6, and it is always, 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 always the number being multiplied in front of just the x to the understood power of 1. And what the heck, we're going to go ahead and do c. The c is always going to be that constant that doesn't have a variable attached to it. So it's going to be negative 1. Okay, so here let's just substitute. So this is going to be negative, and the b is a 6 over 2 times the a, which is a negative 3. So this is going to be negative 6 over negative 6, and negative divided by negative is a positive, and 6 divided by 6 is 1. So now wherever I see an x in the formula, so f of 1 is equal to negative 3 times 1 squared plus 6 times 1 minus 1. If you do that in your calculator or in the noodles that God gave you, doing order of operations, so 1 squared is 1 times negative 3 is negative 3, 6 times 1 is plus a 6 minus 1. So negative 3 plus 6 is 3 minus 1 is in fact 2. And so your vertex is your x value, which is the 1, and the y value of 2. So a little bit of extra work there, algebraically. So the y-intercept. Let's compare the y-intercept. So the y-intercept is hard to see in the vertex form, but it's very easy to see in the general form. So the y-intercept technically is the x is always 0. So in the formula, in the function, wherever I see an x, I'm going to put a 0. So f of 0 is going to be, so this is going to be negative 3 times negative 1. 0 minus 1 is negative 1. Negative 1 squared is a positive 1, plus 2. And this is going to be negative 3 plus 2 is negative 1. So my y-intercept, that's my short for y-intercept, is 0 comma negative 1. This is my x value and this is my y value. In the general form, it'd be nice for us to see that this right here is going to be our y-intercept all the time. But if you don't see it, then again, you would do the same process. When x, wherever you see an x, you're going to put a 0. Zero squared is 0, times negative 3 is 0, plus 6 times 0 is 0, minus 1 is in fact the negative 1. And so my y-intercept, my x's are always 0, and my y value is negative 1. Now graphing them. So granted, there's graphing utilities. So that's, if this is your last math class, go for it. If you're just beginning, you want to know how graphs behave without using the graphing calculator as a crutch. So here we go. Example, sketch a graph of f. So f of x is equal to negative 4x squared plus 4. So right off the bat, again, it's a squared, so I know it's a parabola. I know that this is negative, so I know it's a downward. Some people like to, downward or upside down. Some people say that like that. So I know it's a parabola, highest power is 2. The -4 means that it's upside down. Okay, so this is the general form. So first thing I'm going to do is find the vertex. So first find the vertex. And I need to remember that I'm going to use x equal to -b over 2a. So my a is going to be -4. So I got that one from here. Remember that your b is always a value that's multiplying just with an x. So since the x isn't there, the only way it goes away is if you're multiplying it by a 0. And then the c is the constant by itself. So this is going to be our c. Okay, so let's substitute stuff in. This is going to be -0 over 2 times -4. So this is just going to be 0 over -8, which is just 0. And some of you might say -0 over -8. It's still 0. All right, so our x value is 0. And so technically here, if I wanted to start making a table, so let me make a table. So when x is 0, now I'm going to substitute it in. So I'm going to find my y value, find f of 0, which is my y value. So wherever I see an x, I'm going to put a 0. So 0 squared is 0, times -4 is 0, plus 4 is 4. So 0, 4. So I'm going to go ahead and start graphing it. So there's 0, 4. And I know that's going to be the highest point on my parabola because my parabola is upside down. And so now after that, we're just going to pick x values to substitute in. So here, my axis of symmetry. So let's go ahead. I know that my axis of symmetry goes through the vertex. So my axis of symmetry, I'm going to write it here. My axis of symmetry is always x equal to, and in this point, x is going to be equal to 0. And this 0 again is that 0 right there. So I'm going to pick some values, and you can pick any values. So if I'm going to pick 2, I'm going to pick 2. So this is going to be 2. So this is going to be -4 times 2 squared plus 4. So 2 squared is 4 times -4 is -16. -16 plus 4 is -12. So at +2, I'm going to get -12, which is somewhere right there. Now, extending the axis of symmetry, I know that there's another point on the other side, same distance away from the axis of symmetry. So this is going to be -2, -12. And if you don't believe me, you can substitute it in and you're going to get the same value of -12. So let me connect the dots here. So here's my parabola. Definitely upside down. Okay. Second graph. So f of x is equal to 2 parentheses x minus 1 squared minus 6. Again, highest power is a 2. This is a parabola. My a is a 2, so it's going to be an upward or pointing up parabola. I'm not going to write it down. All right. So the first thing that I need to do is find my vertex. So my vertex is h comma k. I have to remember that here's the h, but it's always going to be the opposite because this is technically going to be, so I'm going to put it here. It is always the opposite. So the -1 turns into a positive, +1, and the k is exactly what this value is right here. And this is your x and your y value. So 1 comma -6. So I'm going to go ahead and graph it. There it is. Then I'm going to have my axis of symmetry. Again, it actually is going to go through the vertex. And it is also axis of symmetry. And it is always x equal to, and in this case, x is always equal to 1. Where did I get this 1? Right there. And so I have a table. I'm going to make a table. So x and f of x. So when x is 1, I get -6. And I can pick a point to the left or to the right of it. It doesn't really matter. So I'm going to pick x equal to 0. And I'm going to substitute it in. So this is going to be 2 times 0 minus 1 squared minus 6. So I need to do order of operations. 0 minus 1 is -1. Squared is 1 times 2 is 2. Minus 6 is -4. So 0, -4. Right here. And again, using my properties of symmetry with a parabola, I know that there's a point on the other side of the axis of symmetry, same distance apart, right here. And that point is actually 2, 4. 2, -4. And so there's my parabola.